Alright, so in this video, okay, we'll take a look at more examples on how we can actually apply the sine rule to solve problems involving triangles, involving trigonometry. Okay, so in the previous video, we've talked about the case where the question gives us two angles and one side. Now, in this video, we'll be taking a look at another example where instead of giving you two angles and one side, they give you two sides and, to be very specific, a non-included angle. Okay, so let's take a look at try 12. Okay, in triangle ABC, AC equals to 10 cm, AB equals to 18 cm, and angle ABC equals to 31 degrees. Find angle BAC, angle ACB, and BC itself. Now, of course, there's no diagram given. So if there's no diagram given, always draw out the diagram so that we know the position of the lengths and the angles itself, and we know where is included angle and where's the not included angle itself. All right, so let's draw out the triangle. Okay, again, the time to be accurate, we are more interested in the position rather than the accuracy of the diagram itself. So AC equals to 10 cm, AB equals to 18 cm, angle ABC equals to 31 degrees. So that this is what it means by um, the lengths, two lengths, and one non-included angle. Because if the angle is here, it will be included itself. Okay, so quickly highlight out. Okay, your AB will correspond to the angle at C itself. Okay, your AC will correspond with the angle at um, ABC itself. So now you realize that AC and ABC, these two pairs are already given. So we will probably use this on the right hand side of the sine rule. Okay, and your BC corresponds with this angle over here. Okay, so let's quickly look at what we can find. So we are given AB, so perhaps we can find angle ACB itself. Okay, because since AB is already given, now of course the original sine rule is A over sine A equals to B over sine B equals to C over sine C. But we can easily flip this around so that we have sine A over A equals to sine B over B equals to sine C over C. And the reason why we want to flip is so that whatever that we want to find out is at the top. Okay, so right now, since we have already given these two pairs as the known length and angle, and the opposite length that we know is this angle ACB over here. So let's find angle ACB first. So using sine rule, we have sine angle ACB is over, so the length corresponds to angle ACB is AB. Okay, is equals to, so sine angle, the one that we know is ABC, so sine angle ABC, and the corresponding length opposite the angle is simply AC. All right, so and we can sub in all the numbers that we know. So sine angle ACB is over 18 cm equals to sine angle ABC, which is 31, so sine 31 degrees over 10 cm. And then to find angle ACB first, so before we move the sine over, we need to multiply throughout by 18. So we have sine angle ACB is equals to sine 31 degrees over 10 multiplied by 18. Okay, so let's evaluate that first. So we have sine angle ACB is equals to sine 31 divided by 10 multiplied by 18. So we will have 0.9270107. So equals to 0.92707. Okay, now before we continue to solve, a lot of us will just quickly put there angle ACB equals to sine inverse 0.92707. So a lot of us will have this tendency to straight away put it like this. Okay, and it's not wrong per se. Okay, so you will have 67.982 degrees But you must consider the obtuse angle itself, because we know for a fact that from 7.2 sine 180 degrees minus theta is equal to sine theta. So because of this rule itself, okay, because they are equal, then we know for a fact that my angle ACB can also be obtuse, or 180 degrees minus sine inverse 0.92707. Okay, so you have 180 degrees minus 67.982 degrees. So we will have 112.0178. 112. Okay, and of course, because we want to give it in one decimal place, we have equals to 68.0 degrees or 112 degrees. Okay, so remember your answer must live in um, 1 dp. Okay, so now we have angle BCA or ACB. Okay, and we can find angle CAB or BAC easily, okay, by taking 180 degrees minus 31 minus 68, or 180 degrees minus 31 minus 112 degrees. So that means now we will have to consider two different cases. So we will have um, angle BAC is equals to 180 degrees minus your 31 degrees minus 67.982 degrees. Always use 3dp for angles in your workings. Okay, and you have 81.018 degrees and round off to 1 dp, 81 degrees itself. Okay, so sorry, 81.0 degrees. Okay, or angle BAC equals to 180 degrees minus 31 degrees minus 112.018. So you will have 36.982 degrees. So round off to 37.0 degrees. Again, 1 dp. Okay, so now we have two sets of answers for angle BAC as well. And then the last thing we need to find is of course BC. So BC corresponds with angle BAC, which is the angle that we find. So what we can do is, okay, okay, let's do it here. So the first one is BC over sine angle, so opposite is BAC, is equals to, so the one that we know is of course your AC and sine ABC. So AC over sine angle ABC. Okay, sub in all the numbers. So BC is what we want to find. Sine angle BAC is 81.018. So use your 3dp in your workings. AC is 8, sorry, not AC. AC is 10, sorry. AC is 10 and ABC is 31. Okay, multiply throughout by sine 181.018. You have BC equals to 10 over sine 31 multiplied by sine 81.018. Okay, and BC is equals to 19.178 cm. Round off to three significant figures, 19.2 cm. Or, okay, we can use the other one that we have found, so 37 degrees itself. So we will do the same exact thing. Okay, same exact thing, except that instead of 81.018, instead of 81.018, we will use we will use 36.982 itself. So 36.982, 36.982. Okay, so you will get 11.680, and round off to three figures, you have 11.7 cm. So overall, altogether, you will have two pairs of answer. So your answer will be angle ACB equals to 68.0 degrees or 112 degrees. Angle BAC will correspond equal to ACB, so 81.0 degrees or 37.0 degrees. And BC equals to either 19.2 cm or 11.7 cm. Okay, so I hope you can actually draw a few conclusions from this whole thing itself. The first conclusion is the fact that now we have seen how to use the sine rule, okay, to actually find unknown angles. And the first thing you must understand is the fact that your sine rule can easily be flipped. Okay, now, so this is the first thing. The second thing I hope you observed is the fact that when I solve my sine rule, when I solve my sine equation, when I sine inverse the answer, I will always consider two different set of answers. Okay, because of the fact that I have my sine of obtuse angles itself. Okay, now must I do this every single time? Yes. Will there be a case where you reject um where you reject what do you call it, where you reject the obtuse angle? Yes, we will take a look at that in the next example later on. Okay, but yeah, then we will have two pairs of answers. So this is the thing I hope you notice, that you will have two pairs of answers, two sets of answers, in fact, one set and two sets of answers. Okay, and the last thing I hope you notice, it's not really the obvious, but this is also the proof. Okay, proof why in your SAS proof for congruency, for congruent triangle, okay, your A must be included angle. Because if A is not included angle, then you have something like this, isn't it? Two sides and not included angle. So this is your SSA. And you realize that with SSA itself, I can easily have two triangles that have the same dimension as the SSA, but they are not congruent. Okay, in fact, one is an obtuse triangle, one is a normal triangle. So four things I hope you learned here. All right, now we will take a look at another example in the next video, where it's the same exact structure, two sides and non-included angle, but this time round you will see that we have to reject the obtuse angle, and you will see why. It's very obvious, it's quite straightforward. And of course, from there you can actually derive some sort of a formula to derive whether or not you have to do the obtuse angle or not, but it's quite additional step. If you are interested in it, you can actually read it inside the textbook itself. Okay, um, yeah, so watch out for the next video for the next example.